4.8 part 2, dividing complex numbers. Okay, we cannot divide by a radical. So we can't divide by a complex number because a complex number is a radical or a root because it's the square root of -1. So if for some reason we have a square root, remember this is the same thing as 3 square root -1. So we don't want that root down there in the bottom. So we have to get rid of that root. Now we know that when we multiply two roots together, then they get multiplied out. If I want to get rid of this I can multiply by I over I, because right now I'm not changing this problem at all. When I multiply by something the same on top and bottom, I'm just multiplying by 1. Remember, 1 is still going to be your answer. So when I distribute this to here and here, this becomes 9I. This becomes plus 12I squared. On bottom, there's only one term there, so this becomes 3I squared. And we know, because we're smart people, that whenever you have an I squared, you can replace I squared with -1. 3, -1. So if I simplify this now, this becomes my real number, so that's going to come out in front, so the 12. -12, because 12 times -1, plus 9I over -3. I want to look at my heart. So when I'm looking at this, you're not including the I. What are all of these divisible by? They're all divisible by a -3. So divide each one of these by -3. 12 divided by -3 will give me a +4. 9 divided by -3 give me -3I. If I wanted to, I could have this over 1, but that's not really proper. So this right here would be my answer. Okay, that seems okay. That seems doable. But what happens if I have a real number with a complex number? So if this happens, it's not as easy as just multiplying by the I, because then just like up here, if I multiply just the I will just go back and forth between those two terms. So I have to try to figure out how I can multiply this by something so that the middle term, that might be a hint, could cancel out. I want to multiply by the conjugate. So I have a 1, a 4I, and a 4I. If this is subtraction, I'm going to multiply it by plus. So on top, I'm going to draw a long division bar. I'm going to focus on just the top here first. I'm going to do my first outside, inside, last to multiply. So 2 times 1 is 2. 2 times 4I is 4I. Inside, 3 times 1 is 3I. And 3I times 4I is 12I squared. On bottom, I have my first, I have my outside, I have my inside, and I have my last. Negative times a positive is negative 16I squared. So one thing that's nice about when you multiply by the conjugate, meaning the first two numbers are the same, just different sign in between, these two cancel each other out. Wham, bam, thank you, ma'am. I can also combine these two together because those are both i's. So I'm going to rewrite this as 2 plus 4I plus 3I would give me 7I. And then remember, I squared is -1. And on bottom, these two cancel. So I'm going to have 1 minus 16I squared is -1. Be careful right here. Now what I have is 2. I'm writing out a lot more work than I have to, but sometimes I need to be able to visually show you guys. So all I did right here is multiply by the -1, multiply by the -1. Notice how this is like a -16. So I do my final combinations. 2 minus 12 would give me a positive or -10 plus 7I over 17. So my overall answer would be -10 over 17 plus 7I over 17. I want you to pause the video and try to do C. Try to do C by yourself, which is multiply by the conjugate first. So your conjugate that you should have multiplied by was 3 minus 4i, because this one says plus, so the 3 and the 4i don't change. And one thing that you notice, so I didn't have to write this all out, I personally cross out this whole thing, and I multiplied by -1, so I rewrote this as subtract 8. Here, I rewrote this one as plus 16. So I can combine those two to get 7, combine these two to get -26i. These two cancel. 9 plus 16 is a 25. So my overall answer, this is subtraction time, looks like that. So right now I want you to pause the video and try to do these 3. Remember, this one doesn't have it, adding, subtracting, so that will be like this first one, like A. So here, I multiply by I over I. Again, when I had the I squared right here, I crossed that out and put a positive 1 because this was a negative minus a negative 1, positive 1. Here, cross that out because negative 1 times 6 is negative 6. And then I rewrote the real number first and then imaginary. Okay, so my final answer then looks like this. How did you do that? Well, 1 divided by negative 6, that's a negative 1/6. 4 divided by negative 6, that's subtraction. 4 and 6 are both divisible by 2. So that's where the 2/3 I comes from. Here my conjugate is 8 minus 7i. So again, these two cancel each other out. I rewrote my I squared, so this becomes a negative 49. I squared times a negative 49, this is positive. So on top, I add these two together, I get 15. Add these together, I get negative 112i. And bottom, 64 plus 49. Here's my final answer. And my conjugate for the last one is 8 minus I, and 8 minus I. So this becomes 56i. This becomes a negative 7i squared, which actually becomes a positive because I squared, remember, is negative 1. So negative 7 times negative 1, that's where that positive 7 comes from. This becomes a positive 1 because minus a negative, you get that positive 1. These two cancel. If for some reason these don't cancel, you probably picked the wrong conjugate. So make sure to be careful with your work. And now I combine my like terms. I get this, split up my two fractions, bing, bada, boom. And there you have it. See? Now we get into the second part of part 2. So finding the pure imaginary solutions. So what are the solutions to this problem? So when I'm looking at this, I have to solve this. I just have one variable there, so I'm going to solve mathematically. So first thing I'm going to do is subtract over my 32. Next thing I'm going to do, I'm going to have to get rid of that division first. So now I have x squared is equal to negative 16. To get rid of something squared, I have to take the square root. Now, x is going to be equal to, there's two numbers here, so positive and negative. There's a positive negative because 5 squared is 25, negative 5 squared is 25. It's that same concept here. I can rewrite 16 and negative 16 as square root of negative 1 and square root of 16. Square root of 16 is 4. Square root of negative 1 is I. So now those are my two solutions. I should have two solutions because of x squared. I want you to try to do these two right now. So here you subtract the 20, divide by 5, take the square root. Again, there should be two answers here. There's two answers here. And square root of 4 is 2, square root of negative 1 is I. Here, subtract the 15, take the square root. So positive, negative, whenever you take a square root of something, there's two answers that x could be. Now I have my I because it's negative, and I can't simplify the square root of 15. So what if I have an x squared and an x? Well, this is where the quadratic formula comes into play. So my a value here is 2, my b value here is negative 3, my c value here is 5. And you plug this into your quadratic formula. Remember that when you're plugging into quadratic formula to make sure that it's in parentheses, simplify this discriminant right there. Now I'm going to have a square root of a negative. I want to see if I can simplify the square root of 31. I can't. 31's prime. But you can simplify this negative. So this becomes 3 plus or minus, because this is like a square root, negative 1 times square root 31. Square root of negative 1 is I. And I still have my square root 31 over 4. I can't simplify this any further. So my final answer would be 3/4 plus or minus I square root 31 over 4. I want you to try to do B right now by yourself. A is 3, B is negative 1, and C is 2. Plug it into your quadratic formula. You should get their discriminant to be a negative 23. 23 is also prime, but that negative can become an I. So if I split this up, I have 1 divided by 6 plus or minus I squared 23 over 6. I want you to try to do this one next, but first thing you should do, remember, you have to set this equal to 0 before you can do anything with the quadratic formula. So this one's a little bit different. So you plug into your quadratic formula, you simplify your discriminant, you get negative 4. Just like up here, when we had the square root of negative 4, you can simplify that. So now what I have is 4 plus or minus, this becomes the square root of 4 is 2. Square root of negative 1 is I. That whole thing divided by 2. So I can simplify this by looking at my heart. Notice why I do not include the I. All three of these are divisible by 2. So divide by 2, divide by 2, divide by 2. I could have that over 1, but I don't need to. So this right here would be my final answer. You would still get this if you wanted to split it up like 4 over 2 plus or minus 2i over 2, just like how we've done over here. But then you would have to simplify your fractions to 1 and 2. And there you go. See? Easy peasy, lemon squeezy. Have a great ZZZ day.